Machine learning operations or MLOps is an emerging field. In the coming years, there will be lots and lots of jobs around MLOps as the things are progressing. Machine learning operations is a nascent field that deals with operationalizing machine learning. MLOps roughly refers to a set of processes or methodologies designed to ensure reliable and efficient deployment of machine learning models in production. There are six stages in MLOps, and as you can see on your screen, those six stages refer to this machine learning lifecycle. Let me quickly go through those six stages so that this diagram will be more clear to you. The first and foremost stage in MLOps is called as data collection and cleaning. This is the first task in any typical machine learning project. Data collection refers to collecting data from various sources. Data can be sourced from your databases, which could be your RDBMS, NoSQL, in memory, or whatever sort of database that is. Then the data can also be sourced from scraping the internet, like reading the wiki pages, going into Stack Overflow, stuff like that. Data can also be sourced from a lot of API endpoints. For example, if there is a IoT devices which are sending or streaming data, that is another data source which can be collected as part of machine MLOps data collection. Once the data is collected, the next step is to clean it. By cleaning, we mean labeling the data and other data transformation activities where the needless data is discarded, and that depends upon your use case. Second stage of MLOps is called as feature engineering. Once data is collected and cleaned, you are not done with data yet. You may want to create new features, transform the existing features, or extract new features from the existing features. That's what feature engineering is all about. It is a process of using domain knowledge to create new feature or to transform the incoming or source data into whatever your use case is. Feature engineering is typically done after data cleaning and before building models. And yes, building model and training model is the next step. Model building is a step that follow data pre-processing, which we just discussed. This kind of model and the tool you use roughly depends on the data set and the problem. For instance, when working with structured data and performing discriminative tasks, your model may be something like a random forest or support vector machines or linear models. When performing image classification on a large scale dataset, your model may be based on convolutional neural networks or CNNs. When doing sentiment analysis, your model may be based on recurrent network or fine-tuned BERT. After designing the model, the next task is to train it. Model building and training are iterative processes and they involve a lot of experimentations. Once that's done, the next stage is about model evaluation. On the course of training, a model is evaluated on validation set. Validation set can be a portion of training set that is not used in training a model. To compute performance metrics such as accuracy. Performance metrics depend on problem and data set. For classification tasks, your performance metric can be accuracy. For regression, your metric can be mean squared error or MSE in short. Validation data are different to test data. Validation data are used to evaluate the model during training, while test data are used to evaluate the final model after training. When the model is good enough, the next step is to deploy it. So, which is the next stage, of course. Model deployment is the process of putting model into production to make it easily accessible to users, developers, or other applications. Model deployment is one of the last stages in machine learning lifecycle. Model can be deployed on cloud or on the edge devices. The last stage is model monitoring. This step involves watching the performance of the deployed model over time. Real world is messy and many things can go wrong. Over time data can change, which is called as data drift, or a model can decay, which is called as concept drift. It's important to monitor relevant data pipelines, or any other pipelines, and tracking key metrics so you can know when things break or there is a bug causing misprediction. So these are the six stages which correspond to the life cycle which is shown on your screen. Designing machine learning models is an iterative process. The machine learning life cycle stages represent a rough overview of tasks involved in shipping ML models, but it is not exhaustive, and some stages are not straightforward, and that can depend on your use case too. While most of us spend time on building models, models is a tiny thing in entire ML life cycle, and there are other things that are not necessarily related to machine learning. So this is a quick overview of machine learning operations or MLOps, and as it is an evolving field and lot of things are still in a limbo. So please keep an eye on this channel because I'll be posting more and more MLOps videos so that you would be able to get the job as MLOps person easily. I hope this was useful. If you have any feedback, please put it in the comment section. Thank you.